Hi, my name is Diana and I'm here to present my team's lasigeBioTM approach to BioCreative Track 1, which had the goal of text mining drug and chemical protein interactions. The greatest motivation of our methodology was the usage of external information, so instead of relying only on the training data, we also relied on entity information in the form of biomedical ontologies. Therefore, what we did was associate each entity in the training data with the term in the biomedical ontology and use that information about those entities to add extra knowledge to our overall system. We thought that using this external information would improve the overall results compared to just using a baseline deep learning system such as BLSTM and BERT. And we had evidence to think that this would yield good results because our team already had created the BiOnt system, which uses multiple biomedical ontologies to extract relations between biomedical entities, and that was tested on multiple datasets. So we thought that just adjusting the steps that we did for the other datasets will produce reasonable results. However, that wasn't quite as straightforward as we thought it would be, and we couldn't get from direct application or just minor adjustments with the BiOnt system the results that we expected for the track. So instead of going through our system and explaining all the different parts, I'm just going to focus on what makes us different and why we think that we could do better with the approach that we are proposing. The first relevant thing is that instead of considering only the 14 provided labels within the training and development datasets, we added an external label, a label of no relation. Because the test and background datasets that were provided to us only had the entities mentioned and not the relations that we should all consider, we had to teach the system what wasn't a relation. So instead of only having positive labels, we added a label that transmits the option of two entities being mentioned in the same sentence and not being related for all non-labeled co-occurring entities. Also, to add the extra external knowledge that I mentioned previously, we linked all chemical drug to the ChEBI ontology and all gene protein entities to the Gene Ontology. This last one we did via secondary steps. Since we can't link them directly to an existing ontology, we linked them to their most representative Go term within the Gene Ontology. These terms describe gene and protein functions and not the entities themselves. So here you have a system overview where we had a pre-processing, a training, and a post-processing stage. Our system was built using bidirectional long short-term memory networks, incorporating word-to-word embeddings, and makes use of different combination of input channels to maximize performance. One of those channels is the ontology embedding layer. In this channel, if we were considering a relation between two entities, if their ancestors already had an established connection, we reinforce the relation that we were trying to determine, as you can see in this image. We also experimented with the usage of class weights for some models in order to reflect the different relation between labels. But our problems were mainly in the pre-processing stage, because our system will not allow for the vectorization of the sentence where the entities considered overlapped, and also the pre-processing stage was quite a slow process, because in the past we had dealt with significant smaller volumes of data and we never had to optimize for large volumes such as the provided dataset, so it took too long to process all of the data and we ran out of time to do all of the adjustments that we planned to do at the beginning of the task. Therefore, our post-processing stage focused on damage control by recovering data that we had lost in the beginning of the pipeline. So we not only included relations that were not included, but also included relations that were considered false negatives, and for both we compared them against detected positive relations within the same document between the same entities and simply assigned the same label. So if the entities were already described in the document and the same entities were already assigned a positive label, we assigned the same label. However, not even this last stretch of post-processing rules could save our results. So, as you can see by our table of results, compared to the average task metrics made available by the task organizers, we were quite low in performance with our system, failing mostly in the labels that had the least training examples, as these representation percentages show. However, we also did not perform well on labels that had more training examples, but were complex or built using multiple tokens or represented a more variety in the sentence formation. So, to conclude, what we think will significantly improve our results is improving the pre-processing stage in terms of how we process the data and how fast we do it too. And also improving the rules to capture dataset specificities as the ones that were demonstrated in the previous slide regarding the product off label. And with that, we are quite confident that after improving these stages, we can get to the results that were demonstrated by the other teams. So here are my main contacts, so if you have any doubts or any suggestions, we are open to listen and answer them. Thank you.